Hi everyone, I'm Neha Kardam and this is the sixth lecture on printed circuit board fundamentals. In this lecture, we will talk about controlling the track width. We will improve the electrical characteristics of the PCB by increasing the width of the ground and VCC tracks. It basically involves creating custom tracks, widths, and then applying one of those to new or existing track. So let's see how we do it. So for that, you need to go to the setup. So the setup you can find on the top of the Ki-CAD table. So here we have a setup here. So we'll click here on the setup and then we'll click on the design rules. So now you're on the design rule window. So once you're here, click on the global design rules. So this tab you see here, this is the global design rule and this is the net classes editor. So when you click on the global design rules, you see these routing options, different minimum track widths, minimum via diameter, minimum via drill holes you can use. And here are the custom via sizes and custom track widths presented here. Now we have set up already the track widths and via diameter based on our schematic design. You can change this number to 002 or something like that based on your design, but I'll keep it like this because this is what the requirement of my circuit is. So let's keep this value as it is, and same like above, you can change any value over here of your track widths. So all these tracks are there present in your schematic. So as you can see here, this is my schematic, and in this they are different. Each of the track has its own name, and I am changing the track width by this custom track width option. So you can change it. Right now I have already set up on a right dimensions, so I'll just click OK. So once you click OK, then the next step what you have to do is to check whether the change you have done is appearing here or not. So to check that, you can see here, these are the tracks I use. I use 0.01 mm and 0.250. So all these things all these dimensions I use for my tracks, and they are visible over here. So now let me go back so that you see it again. So design rule check. So you remember 0 0.01, 0 0.02, 5, 0 0.05, 0 0.08, 0.1, 0.15, 0.2. So these were my dimensions, and again I'm checking it again here. So you can see all these values I set it up on my custom track widths. Okay, so this is the way you can change the track widths. Now let's change the width of the VCC track to something bigger value. So for that you will click on these VCC trays, and then you will go to the properties. So when you click on the properties, you will see this via track and via properties, and here you have the option to change it to a new dimension. So let's say let's change this to maybe 50, and then click OK. So you can see how this track has changed from the previous value. We can do it again to check if there was any difference or not. Properties, and then maybe just click 02 again. See, you can see the difference, how the width is increasing and decreasing with the change in dimension. So this is how you can change the track width. And now we will see how we can calculate the appropriate track width. So to do that, you need to click on the so you need to click on the home page, and then here you see this calculator. Uh, to use this calculator, you need to click, and then here you can see how many calculators I have opened. So I'll just no, and let's use this. Okay, so this is the PCB calculator window, and you can see there are so many options like regulators, track width, electrical spacing. You can change the spacing over here, transmission line, the spacing you can change, microstrip, coplanar, waveguide, and all these options are given. RF attenuators, color code, board classes. So all these specifications are given in this PCB calculator. So let's just understand how we can have a track width based on our based on these parameters. So what I'm going to do is I'm going to change the current, and I'll see how that reflects on my trace width and trace thickness. So let's change current to maybe to 1.0. So did you observe the change that when I change the current over here, the thickness here has changed. So previously it was 2.5 amps, and the trace width was 1.06307, and trace thickness was 0.035. So let's change this and see the difference. So now you can see with 1 ampere of current how the trace width has increased to 0.300387, and now the trace thickness is 0.035. So and these are for your external layers, and if you have any internal layers, and then that will also be affected by the change in the current and all these parameters like temperature rise, conductor length, resistivity, all these values. So this is how you use the calculator on the Ki-CAD. And also you can change the dimension over here if you want in centimeter, inches, mils, etc. You can use that, same as here. So there are so many options given on your Ki-CAD, and you can utilize that to create your schematic with appropriate dimensions. Now what we're going to look next is annotating the schematic, and for that I'll take this example. So right now you can see here all these connections you see, these are not annotated. They have like question mark over here. So what I want to do, I want to annotate all these connections. So for that, what we can do, we can go up on the top bar of this window, and if you click on this, you see this is a scope, order, numbering, options. You can choose this, use entire schematic, or you can just click on use the current page only in case if you are working on a multiple page on Ki-CAD. So this you can do, and sort by components by X position or by Y position. So all these things you can use. So what I'm going to do now, my schematic is not annotated. So I'll click on this annotate tab, and let's see. Do you see any change? So all these are now annotated. And if you think that the numbering is not correct, you can further click on individual, and then so for example, I clicked here and I can change this to maybe let's say 22. So you have J22. So you might be thinking, why did I have to go through this path and then do the annotation? Why, if I can do it easily over here? The reason is because sometimes in the schematic, you have lots of components, and it takes a long time to go through each of them. So it's better to go through here and annotate at the same time all of them together. This is it in this. Thank you so much for watching the video.